Seeing that sample return capsule gently land in the Utah desert on 24th of September was unbelievable experience. Don't have words to articulate it. I was sitting in a room of the Command and Operations Center, one of the people who would make decisions if needed to make decisions. And wow, it was incredible. And on the 1st of October, we moved into the analytical phase of the mission now, which of course I'm in charge of coordinating the whole process globally. We have an international team of about 200 to 250 scientists, lots of students, postdocs, that are all involved in this process. I don't think any of us didn't cry with tears of joy when we saw the parachute come off and land gently. For 15 years I've been waiting for that moment, and wow. So as you probably saw in NASA media, we have the science canister which was opened up, and we saw that the main collector was intact inside the science canister, and yet we had dust around the outside of it, quite a significant amount. So we had a delightful job of slowing down to collect most of that dust, that was all of that dust that was there, and prepare for the next parts, procedures of unraveling what's actually in the container, which we haven't done yet. Knowing that we have minerals that contain water, either bound or trapped in their different structures, was something that we had predicted from the operations phase. When we actually scanned the surface, we noticed that there was a richness in minerals that contain water. So it was a confirmation that was incredible, because it's one of the main goals of the mission was to go and collect sample that could potentially give us clues to the origin of water on Earth. And we've done it successfully. Having 2 data points now from 2 different asteroids where we have hydrated minerals is really telling us a story that we have to get finished to write, because we haven't finished analyzing the sample of OSIRIS-REx. We've only just started. So one of our goals will be to relate our findings with that of the Hayabusa 2 team as we analyze and continue to move through. It certainly adds a really important point to the hypothesis that asteroids were one, if not the, bringer of water to Earth. And we're really excited about teasing out the rest of the information the sample will provide for us. We're also looking at the total carbon of this sample, which is about 5%, which we're very excited about. And one of the goals of the OSIRIS-REx mission is to look for prebiotic compounds that may have been the foundation of life itself. So, of course, everyone knows that in order to have life, you need water, you need oxygen, you need carbon, and you need an atmosphere. But of course, you also need something else, a planet. So the mission is geared to look at all those different variables. How do you make a planet? How do you get water on a planet? How do you deliver or have prebiotic compounds that eventually become life itself? So that's what we're going to be teasing out and exploring and investigating in the samples. So one of the goals of the OSIRIS-REx mission was also to help security, in this case, to better be able to predict when asteroids may hit the planet. One thing we don't know about these predictions that you hear in the news all the time, asteroid such and such has a 1 in whatever chance of maybe hitting the Earth, is we don't know the composition of the asteroids. So by analyzing the sample in more detail, we can better fill in that variable of the equation to help make our predictions sturdier. We don't know if it represents all carbonaceous asteroids either. Certainly a small percentage of them, maybe up to 20%, have that top-shaped appearance. And yeah, we learned a lot, and also the fact that when we collected the sample, that the asteroid itself is held together almost exclusively by gravity, which we didn't expect. We expect some tensile forces in there as well. Wasn't there. So the next steps is the actual implementation of the sample analysis plan, a 300-odd page document that we worked on for years that will coordinate integrated analysis across the globe with different laboratories in Japan, in Australia, in France, for example, in Germany, UK, Canada, etc. And through that integrated process, we will really be able to understand what is the origin of the Bennu material before it even became its parent asteroid. What happened in the parent asteroid of Bennu? What happened after the parent asteroid broke up? How did Bennu form? How many times has it been reformed? And what is the current state of the asteroid? That's what we're looking at. As you can probably see by my face, I'm ecstatic. I mean, since I was 5 years old, growing up here in South Jersey, I've loved rocks and fossils. And all I ever wanted to do is be a geologist. And I watched the first men walk on the moon at 4 years of age with my mother sitting next to her on the couch. And boom, now I'm doing my life passion again and again and again. I feel like a high school kid again with the curiosity of science.